Today's video is on lessons 4.6 and 4.7. 4.6 is on exponential modeling with percent growth and decay. You will notice at the top of your page there are two formulas. Hopefully you can figure out that the first one is for growth. And the trick here, or what I noticed to help me figure out that this one was growth, is that the rate inside of the parentheses is 1 plus the rate. So you're growing. This one is for decay, the one next to it, with the minus. It's 1 minus the rate, so you're getting smaller. You're decaying. These letters stand for the following. A stands for the amount, which is the final amount. So if you're talking about like a bank account, it's how much money would be in your bank account at the end of a certain number of years. P is the principal. That's your starting amount. That is like how much you would put in your bank account starting out. So if you deposited $400 and then it grew at a certain rate for a certain amount of time, your principal would have been that $400 because that's your starting. R is your rate. Now you have to be careful because when you plug in the rate, it needs to be in decimal form, not in the percent form. Not a percent. So you need to convert. If it is given as a percent, which if you glance down here at exercise 1, it is. It's given as 5%. You need to convert it into a decimal by dividing by 100. So if I gave you a percent of 20%, to convert that, you would do 20 divided by 100, which is 0.2 or 0.20, but 0.2. So be careful. That should be like the first thing you do is you take your percent and automatically turn it into a decimal. Time is in years. So also be careful there. Make sure they gave you your time in years. You may have to convert. For example, if they gave you 12 months, that's 1 year. So you'd actually be plugging in 1. Okay, so let's read through the first example. It says, suppose that you deposit money into a savings account that receives 5%, which again, above the 5%, I'm going to write what that is as a decimal. 5 divided by 100 is 0.05. The other trick that you guys learned, I don't know, when you first did percents, maybe back in 7th grade, to convert a percent to a decimal, you just move the decimal point 2 places to the left. So you can do that a little quicker in your head if you just know that trick. So the savings account receives 5% interest per year, so for every 1 year, on the amount of money that is in the account for that year. Assume that you deposit $400 into the account initially. How much will the savings account increase by over the course of the year, so over 1 year? So we don't actually have to use any of our formulas yet because we're only figuring out how much money we are increasing by over 1 year. Well, we know we're going to get 5% of this. So if I multiply 400 times 0.05, that is $20. So I am increasing by $20, which means now part B says, so how much money will be in the account at the end of the year? Well, you had the 400 you initially deposited, plus the $20 you make, which is $420. So what this question is doing, it's really breaking it down for you step by step. Normally, they're not going to ask you this many separate little questions. It'll be just one big question. You'll have to do all of these steps within the question. Part C, by what single number could you have multiplied the 400 by in order to calculate B? So what could you have multiplied 400 by to get 420? So what you're going to do you agree that to get 420, we did 400 times 0.05, and then we added on, that was 20, then we added on the 400 to get 420. Well, if you factor out, if you notice these two terms here on the left side of the equal sign, both share a 400. So I can GCF out a 400 or divide a 400 out of both terms. In the first term, I'd be left with just 0.05, plus in the second term, I'm left with nothing. But remember, if there's nothing there when you divide 400 by 400, it's really a 1. So now if we rewrite this, this becomes 400 times 0.05 plus 1 is 1.05. So this number right here is huge. This is your rate. This is what you were growing by, and it should make sense. We had 100% of our money. We had the $400 plus an additional 5%. So if you think about this as terms of a percent, this would be 105%, which should make sense. Again, like I just said, we had 100% of our money plus an additional 5%. So we had 105%. Great. Part D says, using your answer from Part C, determine the amount of money in the account after 2 and 10 years. So we're going to do 2 problems here. Round all answers to the nearest cent when needed. So if we use our formula, we are growing. We are gaining money. So we're going to use up here, we're going to use the A equals P times 1 plus R to the T. So we don't know the final amount, so we don't know A. The principal was 400, that's how much we deposited. Our rate was 1 plus the 0.05, which we found down here to be 1.05. And then T is the exponent, that's how many years. The first one we're doing is 2 years. Now you just type this all into your calculator. Remember, if you're doing this step by step, you got to do exponent first and then multiply by 400. Turns out to be $441. Now do the same thing, but instead we're going to calculate it after 10 years. So I still started with 400. The rate was 1.05, but this time the exponent is 10. That turns out to be $651.56. Part E, give an equation for the amount in the savings account as a function of the number of years since the 400 was invested. So what they really want you to do is write out our equation, but they told you what to use. They want you to use S of T. S, I'm assuming they chose S for savings, and T is time. So the savings in terms of time would be, for this particular equation, 400, because that's what I started with. My rate was 1.05 to the T, which is you would plug in whatever time you're trying to find. Part F, now using a table on your calculator, determine, so you're going to graph this. So for this part F, you would take your calculator and graph that function. If you want to use X and Y instead of S and T, you can, just for the calculator purpose. When you graph it, they want you to figure out to the nearest whole year how long it will take for the initial investment to double. So 400 to double, that would be how long until you get $800. So you're just going to start looking at all of your inputs, your X's or your T's, whatever you call them, and find when do you hit 800. So if I look at the year 14.2, that turns out to be $799.74. If I look at 14.3, that is $803.65. So you can see that somewhere between 14.2 of a year and 14.3, I'm going to hit 800. So to the nearest year, you will notice 14.2 and between 14.2 and 14.3, that rounds down to 14 years. So it's going to take 14 years to reach $800. Okay, the last exercise. So this is a little tricky. So you really have to pay attention to this exercise because what I'm about to tell you, you're going to need for the next lesson. In this exercise, it says to state the multiplier or the base, you would need to multiply by in order to decrease a quantity by the given percent listed. So let's take it back a second here. I'm going to do a little work underneath this squiggly. When we were increasing, so in that last example, we were increasing by 5%. We did 1 plus the percent that we were going up by. And 1 stands for, in terms of percent, 1 is equal to 100%. Okay, so if I said the probability of an event happening is 1, that means it's certain to happen. There's a 100% chance it's going to happen. Plus we added on the percent. So if it was 5% increase, then it was 1.05. Well, if we are decreasing, you're going to do 1, which is 100% minus that percent. But remember, it's as a decimal. So if we, going back up to exercise 3, if we wanted to know what would we multiply by to show a 10% decrease, you are basically taking, if you think about like a pizza, if you want how many, if there were 10 slices and you wanted to take away 10% of that, you would take away 1 whole slice, which would leave you with 9. So you would multiply by 0.9 or 0.90, right? Because 10% is 0.10 or 0.1. So to figure out what you would multiply by to get 10% less, you would be taking 90% of it. 90% is 10% less than what you had. If you wanted, so 2% as a decimal is 0.02. If you wanted 2% less, so here's the math I'm kind of doing in my head. I'm doing 1 minus 0.02, which is 0.98. So if you multiplied by 0.98, you'd be taking 98%, which means you're losing 2%. And that's what we wanted. We wanted to know what would we multiply to lose 2%. The next one, 25%, is 0.25. So if you do 1 minus 0.25, that is 0.75. So 0.75 is what you would multiply by to lose 25%. You'd be keeping 75% of it and giving away 25%. The last one's a little tricky because this is really a tiny, tiny number. 0.5% is 0.005 as a decimal. So when you do 1 minus 0.005, that turns out to be 0.995. So it's going to be close to 1 because you're only losing half of a percent. Okay, so that's it for lesson 4.6. We're going to talk about, especially a lot about exercise 3 in the next lesson. So moving on to lesson 7. Lesson 7 deals with mindful percent manipulations. This one's not very long, but before we start, this is using our 2 formulas from last lesson. It was P times 1 plus R to the T, or if it's decay, it was P times 1 minus R to the T. So remember, T was in years. Well, what if we want to find the monthly growth rate? What if I wanted to take my money out of my bank account after 2 months instead of a whole year? So you have to recall that 12 months is 1 year. And in case they ask daily, it's the same process, but you have to know that there are 365 days in 1 year. So we are going to look at a couple of things, actually. We're not going to get to this monthly stuff until the second question. The first question is a little different. You actually have seen this, but it was back in 7th grade, so you may not have remembered it since then. So let's read through the question. I'll explain what we're going to do. It says the population of gnats increases yearly at a constant rate. In 1 year, the population, and here's what I'm going to underline, it increases from 600 to 680. Find the yearly growth rate to the nearest tenth and express the yearly growth factor. So the yearly growth factor is since we're increasing, it's going to be the 1 plus whatever that rate is. So first we're going to find, I'll put the word rate in there. First we're going to find the rate. To find the rate at which it's increasing, here's the formula. This is the formula for the percent of change. How much is it changing? It could be increasing or decreasing. They use these types of questions a lot in population, especially, usually it's with towns, like if the population of one town went from this number to this number, what percent did it change by? So you're going to do the difference. Remember, difference means subtraction. And this is why I underlined over here, because you need to divide by the original or starting number. So you have to know, did it start at 600 and go up to 680? Or did it start at 680 and go down to 600? So you got to be careful that you know which one did you start at. So that's why I underlined who I started at. So the difference is 680 minus 600. And then we're going to divide that by the original, which was 600. So that's 80 over 600, which turns out to be 0.1333. It goes on forever with these threes, okay? Now that is a decimal, which is fine, but if you wanted to talk about in terms of a percent, you would just multiply it by 100, which means you move the decimal 2 spots to the right. So it is 13.3% is the growth rate. Now we're going to take that and express the growth factor. So the growth factor is basically asking you, well, what would you multiply by to show an increase of 13.3%? So that's where you take, since we're increasing, we're going to add on to 1 our percent, but we're going to add it on as a decimal. So it would be 1 plus 0.133, which equals 1.133. So this is your rate, and this is your growth factor. So please notice the difference. The rate is usually listed as a percent, unless they turned it back into the decimal. And then the growth factor is either 1 plus that rate or 1 minus that rate. Okay, so now this next question deals with monthly. It says the yearly growth of a new population of gnats can be modeled by this equation. You'll notice, look, this is like our A equals P times 1 plus R to the T. So you should notice that because this number is bigger than 1, it's increasing. If it were smaller than 1, it would be decreasing because it would be less than 1 because we're subtracting from 1. It tells us G of T is the number of gnats and T is the time in years. 500 is the starting population. What is the monthly growth rate of these gnats? So if they ask you to take an equation that's given in time, or time in years, and they want it monthly, here's what you do. You take your equation and you are going to raise the growth factor to the 1/12, because 1 month is a 12th of a year and everything else stays the same. That's it. So no matter what this number is, if they ask you to go from yearly to monthly, you just raise it to the 1/12. Then you use your calculator and rewrite this, figure out what 1.182 to the 1/12 is. So it turns out to be, now here's where the more decimals you do, the more accurate your answer will be. So I'm going to write out a couple, more than a couple. I'm actually going to write out 1, 2, 3, 4, 5 decimals. So 1.014. Normally I would maybe stop there, but the next number is a 0, and I don't want to end on a 0, so the next number is a 3 to the T. Now make sure you specify to your reader, which is usually me, that this is in months. So the difference is the original was in years, this one's in months. That's why the growth rates are different. Now it says write an equivalent equation using this new growth factor, but they want it equivalent to the original, which means it has to go back into years. So this is a little tricky. So I have to use my new growth rate. If I didn't, guys, I would just use the 1.182 to the T. That's in years. This one's in years. This one's in months. So that's why there's different growth rates. But they want me to use this growth rate. So I have to ask myself, wait a minute. If I use this growth rate in this equation, this is in months. But I want to get back to years because I want it to be equivalent to this one up here. Well, what would you multiply the months by to turn them into years? Well, you would multiply them by 12. So this would turn into 12t. So this is in years. So look at the difference. These are almost the same equations. They have the same starting, the same rate, but the difference is the t's. This one is in years, so it's 12 times the number of months. This one's in months, and so it's just t. Now to check if you did it right, here's what I would suggest for the check. Don't use 1 because sometimes 1 has special properties, so it might not work. Use like 2. Plug in 2 years into the years version and plug in 24 for months into the months one and see if you get the same number. So if I plug into the first one, 500 times 1.01403, and this is in months, so I'd plug in 24, I'm going to get the number about 699. If I plug in 500 times 1.01403, this one's in years, so that would be 12 times 2, which is 24, so you're going to get the same number. Then you should check those 2 years, or sorry, those 2 times back into the original one. Well, the original one was in years, so I would use the 2. And make sure that you get, and you'll get 699 again. So you should check just to make sure you did it right. Pick 2 and 24, 2 years and 24 months, plug them in and make sure you get the same numbers. All right, last question, really quickly. They want you to take this equation in years and write it in monthly growth rate. So I told you the trick is to simply take your growth rate and raise it to the 1/12th power, and then rewrite what that is. So use your calculator. So that's 1200 times 1.01877 to the t, and make a note that this is in months. So what you needed to take away from this lesson was 2 things. You needed to realize the formula on how to find the rate of change. If you're increasing or decreasing, you subtract your 2 numbers and divide by the starting or original number. Remember, it's not always going to be the smaller number, because if you're decreasing, you would actually start with the higher number and go down to the smaller number. So the bottom will change depending on if you're increasing or decreasing. Then the other thing you need to take away is if they give you an equation and it's in years, to convert it to months, you just raise the growth factor to, sorry, this keeps scrolling back up. You raise the growth factor to the 1/12th power, and then just type this part into your calculator to simplify what that is. And just be conscious of if you're working in months or years. And that is the end of lesson 4.7.